So my name is Krishna Rajagopal. I'm a professor in the Center for Theoretical Physics and have been for almost half of the 50 years that we're celebrating. Welcome, everyone. I will be very brief, and you will see me at various times during the day principally telling you things like where coffee and lunch are. To welcome you for real, it's my pleasure to introduce MIT's Dean of Science, Professor Mike Sipser.
Thank you. Thank you, Krishna. Good morning, everyone. Thank you all for coming. It's great to see so many people here to celebrate the 50th anniversary of the Center for Theoretical Physics. As Krishna said, my name is Mike Sipser, and I'm the Dean of Science here at MIT. In its 50 years, the Center for Theoretical Physics has seen its faculty, postdocs, and students make discoveries that have advanced our theoretical understanding of the universe. CTP scientists have pioneered fields such as nuclear and particle physics, string theory, gravitational research, and quantum information. Our new group of younger faculty are poised to make future discoveries in areas such as dark matter, a mysterious substance that in a sense can be felt but not seen. For example, Tracy Slatyer, the Gerald R. Zacharias Career Development Assistant Professor of Physics, explores possible signatures of dark matter in astrophysical data sets. Tracy is our first recipient of the School of Science's Future of Science Award. You'll hear from her later today. The work of the Center for Theoretical Physics depends on the support of agencies, foundations, and individuals who recognize the importance of basic scientific research. I'm especially grateful to the US Department of Energy and its representatives who are here with us today, who have long supported our basic research effort here. The Ealing Center for Theoretical Physics was part of a major renovation that created a beautiful new home for the Department of Physics. That renovation was enabled by a generous challenge grant from Neil and Jane Pappalardo. Virgil Ealings was one of the first to accept that challenge and pledged to support this effort. Though Virgil wasn't able to join us today, Neil Pappalardo is here, and I'd like to thank them all for the beautiful space they gave us. Many other alumni and friends have supported the CTP and the department over the years. I am deeply grateful to all of our donors and see many of you here with us today. We must protect and nurture basic science by providing our brilliant and creative scientists with the resources they need to accomplish their best work. I am thankful that friends of the MIT School of Science are committed to supporting our scientific endeavors. And now I'd like to introduce Peter Fisher, the head of our Department of Physics, who will give some additional remarks.
Thank you, Mike. I just want to add my thanks to the supporters, particularly DOE, NSF, and our patrons who support our graduate program and supported the renovation of the Center for Theoretical Physics, which it really needed. When I first came here in 1994, going into the CTP was frightening. There were people there like Hermann Feshbach, Francis Lowe, Bob Jaffe, sort of. And it was dark and kind of dingy. But thanks to Virgil and Neil's challenge grant, it's now a place of light and collaboration. It's really a beautiful space, and it's really changed the world around MIT. And it's surrounded by a beautiful atrium, which I'm not going to say much more about. I just want to mention a little interchange I had with a group of students. I gathered together the students who were double majoring in physics and electrical engineering and computer science because there are a lot of them, and how EECS is interacting with MIT is a topic of conversation around the Institute these days, and I wanted to get to know these students because they are in my department and understand why they were double majoring and how the department could better serve them. we had a very nice chat, and I was really very happy when I asked them, what are you trying to get out of a double major? And their answer was, they see the professional world they want to go into with the skills of electrical engineering, and in particular computer science, as very exciting, very diverse. They can go a lot of different directions, and that's what they want to do. And it's a lot about making things, creating things, understanding things, and analyzing things. They're majoring in physics because they're curious. And that made me very happy, because the perennial debate of the university is the balance between, the great books, art, fundamental research, and practical training. And this group of 23 students had sort of figured it out their way. And it's an important aspect about MIT that MIT makes this kind of balance easy. In thinking about what I wanted to say today, the CTP is very much in this mold. Many people come to CTP, particularly in our graduate program, which many people in this room support, and I thank you, not intending to go on in physics, or maybe having not decided to go on in physics, and they receive tremendous technical training that enable them to do a huge diversity of different things. And if you look around this room, that's all of you. Many of you have gone and done incredible things outside of physics and are very happy to be doing what you're doing. I'm hoping that you had some curiosity satisfied during your time in the CTP, because that is the other side of it. And I think this is something I want to talk about as MIT moves forward, because we have a lot of new initiatives around MIT that are really focused on professional development and the economy. And I don't want to lose the other part of it that is really important about MIT and a university research, which is just satisfying your curiosity. I think that is equally important. So welcome back to everybody, and I hope you have some curiosity satisfied with today's talks. Thank you.
Very good. We have a great program of talks for today. Our first speaker will be Andrew Childs. He's the co-director of the Center of Quantum Information and Computer Sciences, as well as a professor in computer science at the University of Maryland. Andrew was a student here, working with Eddie Farhi, and we're very glad to have him back. He will tell us about quantum computation and his recent work. First, Andrew, come here.